Okay, so let's go ahead and take a look at exponentials, just what they are and kind of how they behave. There's one particular style of question on the test that I'm a little concerned about that I will address in here. So let's see a little bit about that. I have a few things prepared. And so let's see what we can do here. So if you recall, an exponential equation is any equation that has this type of look where we have a times b to the x. So you want to remember that that means that there is going to be an exponent is where the variable is going to be. Now we had two styles of problem, one where there was growth and one where there was decay. And what you want to remember is that when there was a growth, that meant that the b value, that base, had to be above 0. Decay occurred when that base b was less than 0. As a side note, I do want to remind you that the domain of an exponential is actually all reals. I can let x be anything that I want. Remember, positive numbers are going to yield pretty large numbers usually. Negative numbers yield very small numbers, which is kind of what was going on with the range, and that range was only values specifically above 0. And you want to remember that the base was any number that was above 0, but specifically that base could not be the number 1. So a value that was a growth story would be something like 6 times 1.8 to the x. That 1 represents technically 100%. So we started with 6 and we have 180% growth, or a growth factor of 80%. Whereas over here, if I had a decay value, you might have something like 2/3, and we'd have 0.75 to the x, which means we started with 100%, we lost 25%. So our growth factor R over here was 0.8 or 80%. Over here, our decay rate, R, was negative 0.25 because it's 25% below, or negative 25%. Now, that's a little bit about that, but one thing that can mess with people a little bit is when people play with negatives. So we did have a problem in class where I gave you something, that doesn't really matter what it was, but I had something like 3 times 4 to the 1 minus 2x. Well, right away, this minus right here is actually kind of a tricky little thing. Remember we said never let anything be attached to x, and it has that. So if we were to rewrite this as follows, this would be x minus 1/2. When you look at this portion of the graph right here, and powers of powers actually do multiply, this portion is actually a 1/16, which is clearly far, far below below the number 1. And so as that's the case, that's going to be decay. I really should not have written it this way, but that's kind of weird. It was actually supposed to be above. I wrote that very badly. Sorry about that, everybody. That was supposed to be a base is above 1, or 100%, and base below 1, which is below 100%. But of course, we said it had to be above 0. So 1/16 would definitely become decay. So again, trying to be as quick as possible with this, I was going to give you a couple of sets of data values. And let's see if we can determine which one of these data sets is in fact exponential. Which ones hold to the idea of a times b to the x? So keeping in mind that an exponential is repeatedly multiplying, when I look at this particular thing and I'm looking for the pattern, I notice that this thing is not repeatedly multiplying, it's actually repeatedly adding. In fact, this one was a linear equation. It was a simple linear equation that was like y equals 3x plus something. And I kind of can look at it and say, well, 3 times 5 is 15. 3 times 1 is 3. I needed 2 more to get to there. Notice 3 times 3 is 9. And you know, I got to be a little bit careful because I normally use x and y's, but I'm using a's and b's here. So that would be b equals 3a plus 2. But I'm not going to stress that on this test. We've already addressed linears. We're looking for exponentials. So is this one exponential? Well, I notice from here to here and here to here, it appears that there is something going on. If I divide these two numbers, I got 3/2. If I divide those two, I get 3/2. Like every time I divide consecutive numbers, I get 3/2, which means if I divide, I get 3/2. That means 12 times 3/2 is this, 18 times. So it appears that I am repeatedly multiplying. So it definitely does appear that I have a constant multiplier of 3/2. Remember, this is kind of what we normally think of as x and y. So my answer D is 3/2 raised to the x power. So that would be 3/2 raised to the x power, which I'm actually calling C. And the cool thing about this particular problem is I know that the initial condition right here was 0, so it should be 12. Now again, I don't know about you, but I often feel a little bit nervous about these kind of problems. So what I would do is take 12 times 3/2 raised to the x. I can't use C's and D's on my calculator, but it's not a big deal. And I'm going to go into my table, and I'm just going to let it be in auto mode here. But if I go to my table and I look, do I have the numbers that are mentioned in my table? 0 gave me 12, 1 gave me 18. Hey, I do in fact see the table emerging that I had right there. So I'm pretty confident in that result. Couple more. Now this one I did because I'm like, well, 5 divided by 3 is 5/3, 11/5. These are all different, so it's definitely not exponential. And so for this test, we really wouldn't have to keep going, but I thought it would be nice if I kind of mentioned a little something, is that I noticed that it's growing by this 2, 6, 10 number, isn't it? And so if it's growing by this 1, 3, 5, 7 pattern, you could tell that this sucker is quadratic. Which of course, I'm actually not going to take the time to solve right now. We might do that at a later time, but not right now. And my last one, if I divide these, I get 4, don't I? So as it turns out, what I see is that there's a constant multiplication by a quarter. A quarter of 400 is here, a quarter of 100 is 25. Every single time I'm multiplying by a quarter. So my answer should be 1/4 to the g power, but the bummer is I don't have a clue what A is because I didn't go back all the way to 0. Now, I do know some of you would just go ahead and extend this thing and just keep doing it, but I chose not to. I just thought, you know what, I'm just going to use a point. I know that if I choose to make G 3, it's going to make H 400. And so that would make this 1/64. And so if I wanted to solve for A, all I would have to do is multiply both sides by 64. And 400 times 64 is 25,600 times 1/4 raised to the g power is H, and I believe that should be my story. But again, I don't know about you, but I feel a little nervous when I do problems like that look this hard. But I get 25,600. I got 1/4. I'm going to raise that to the x power, and I'm going to look at my table. And in my table, let's see, at 3, I got 400, 100, 25, and I see the numbers emerging exactly as I had. Now, the last concept that I wanted to hit with you is what happens if instead of a whole bunch of data values, they just give you a graph. And I can tell that this is an exponential growth story. So I know that that base value is going to be something above 1, but I don't really know much about it. But I can see that the initial condition is here is 3. So I'm going to start right there. But I do have a little something that is nice. I have not used this coordinate right here yet. And I chose to write it as a decimal as well as a fraction. Not that it really matters, but what I notice is when I have 7.68 for y, I find out that the x value is 2. So if I wanted to solve this thing for b, all I would want to do is take 7.68 and divide it by 3. And again, I'm going to take a square root. And normally I would put a plus or minus, but I'm not going to do that here because remember we said b had to be positive. So b is whatever the world 7.68 over 3 is. But I do know it better be above 1. So let's find out what that is. So I have the square root of 7.68 divided by 3, and I got b is 1.6. So my final equation was y equals 3 times 1.6 to the x power. Now I've got another problem right here that I would like you to try. So you can either use the fraction or you could use the decimal. It doesn't matter. Notice that it does go through 0, 2. And I'll give you a moment. Go ahead and hit pause on your video so you could try that on your own. Okay, so for me, I know that b is going to be some number between 0 and 1 because it's clearly decaying. I can see my initial condition here is 2. So I'm going to start with 2 times b to the x. I think I kind of like the decimals just fine. So I noticed that when I used a minus 3 for x, I ended up getting 0.8437. So if I took this and I divided it by 2, I've got b to the minus 3, and that's really kind of unfortunate. A lot of people don't like that. So here's kind of the trick that I would use. If I wanted to get rid of that thing, the first one was easy, getting rid of a square, but this time I'm going to raise both sides to the negative 1/3 power because powers of powers multiply, so this would be b to the first. So I'm just going to find out what is 0.8437 divided by 2, and then I want to raise that number to the negative 1/3 power. And I got 1.333, which I know was supposed to be 4/3. But something feels wrong to me about that. Because I just got 4/3, and I'm not exactly sure what I did wrong there because it was supposed to be 3/4 because it had to be between 0 and 1. So I don't really want to redo the entire video here. You can ask me later what I did wrong, but I had an initial condition of 2. The b value was 3/4. I feel like I did something really, really silly in this problem. Raised to the x power, because I know I designed it to be 3/4, and I just did something upside down, evidently, because I got the wrong value. But that's the end of that story. Hopefully that helps other than the mistake that I made at the end. I hate to do that, but I don't really want to redo it because I'm making a lot of these today. So hopefully that helps. I'll see you later.